10, Transformation of Sinusoids. So we're going to start with the basics, and this is kind of just so you guys can know. Really, it's more for you to know what's happening for horizontal stretches and compresses. I should have put a vertical stretch compress in here, but I just did verbatim a problem from 1970. I was not around during this time. Maybe no, actually your parents probably were not around either. Probably your grandparents were. So this is probably one of those questions that maybe your grandpa or grandma maybe had if they took Calculus AP in 1970. So put these points down in here, guys. Put in -3, -3, -2, -2, -1, -1, 0, -1, 1, 0, 2, 1, 3, 0. I got the points from the table, from this graph. I didn't do anything crazy. I'm going to represent this information in two ways. I'm going to write x, f of x. F of x is your y value. I'm going to go -3, -2, -1, 0, 1, 2, 3. I haven't done anything crazy, guys. Oh, I'm just getting the information from the tape, from the graph here. I'm not, you don't have to look at this over and over. You can just get it from the graph. -3, -3, -2, -2, -1, -1, 0, -1, 1, 0, 2, 1, 3, 0. Does everyone know where those values are coming from? You can say no if you don't know where they're coming from. They're coming from this graph. Are we okay? Another way to represent this data or this table, sometimes they call it tabular data. For now, we're just going to leave it like that. Another way to represent this is to say f of -3 is equal to -3. F of negative, all this should be review, I hope. F of -2 equals -2. F of -1 equals -1. I don't see any mistakes. I think everything looks legit so far. F of 0 equals -1. F of 1 equals 0. F of 2 equals 1. And F of 3 equals 0. Just another way to represent the data. Are we okay so far? Nothing crazy, right? Okay. I'll wait for you guys to catch up. Oh, did you guys have a good weekend? Okay, good. I must have written, I was in the zone. I actually was just talking to Montalongo. Was it Montalongo or was it Winters? I can't even remember who I was talking to. I don't know if this is normal, but I must have written like 6 or 7 recommendation letters yesterday, but I already had them. I just made them like super better because I've been writing them since the summer. So I revised them. But on one of them, I took 2 hours to revise it, and it felt like 20 minutes. So I put my phone down, and I just started hammering away, and let me revise, blah, blah, blah. And I thought it felt like 20 minutes. And then when I looked at my phone again, it was 2 hours. And I'm like, I don't know if this is normal. Is that normal? Like, if when you're focused, does 2 hours just go by like that? Okay. Because that happens to me all the time. No, for real. It's like I'll be in this room. Last week, it happened at least one day. I was in this room, and I lost track of time. It was like, okay, I'm going to pack it up at 8 o'clock. It was like 9:45 p.m. And I was like, man, how did an hour and 45 leave? Like, it just, like at 8 o'clock, I was done. Like, okay, I'm gonna start packing it up. And let me just grade real quick. And I was just gonna grade one thing, and then before I knew it, like, what time is it? Like, oh crap, it's almost 10. And then, yeah, I know. Okay, anyways, I'll delete that out of here. All right. Here we go, guys. Here we go. Sorry for going off on a tangent. So here we go. You guys ready? All right, guys, focus, 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 focus. So I have this. It says on the axis provided, sketch the entire graph of y equals absolute value of f of x. So hopefully you know that y equals absolute value of f of x. All that's going to happen is whatever is below the x-axis is going to get deleted. And whatever I take it back. Anything that's below the x-axis is just going to reflect above the x-axis. Does that make sense? It's just going to, or mirror, I guess. Here we go. I'm going to make a table. X, f of x. Actually, I'm going to put an absolute value around it. Absolute value, like that. negative 3, negative 2, negative 1, 0, 1, 2, 3. I haven't done anything crazy, so relax. This has an absolute value on the outside, so that means absolute value of f of negative 3, close, close, equals, well, f of negative 3 was negative 3, so it's just by coincidence. I should have changed the number. So absolute value of negative 3 is just 3. So plot the point negative 3, 3. If I plug in a negative 2, f of negative 2, absolute value of f of negative 2, well, that output was negative 2. And absolute value of negative 2 is just 2. So plug in negative 2, 2. F of negative 1 was, again, that was negative 1. And absolute value of negative 1 is just 1. So negative 1, 1. At 0, absolute value, the output was negative 1. So I'll write that one because I don't want you guys to think. Absolute value of f of 0. That's absolute value of negative 1. And that is 1. Yeah. This in black is absolute value. All right, now I'm just going to write the answer. Oh, yeah, I didn't put the negative 1, 1, 0, 1. At 1, f of 1 is 0, and that's just 0 no matter what. At 2, absolute value of 1 is already 1, so just keep it like that. And at 3, it's back to 0. So plot those points, 1, 0, point, 2, 1, 3, 0. And it looks like this. So, and I know this is not the most exciting stuff because some of this is kind of boring a little bit. Even I'll admit it. But when you love something, you also got to love the boring stuff. So, yeah. So what happened? Everything that was below the x-axis just got what? Yeah, just got reflected. So everything below the x-axis got reflected. What's up, miss?
How do you get the y of x?
How to get the what?
The y value of x.
When x is 0?
Yeah.
I got it from here. And I just did the absolute value of that. You know what I mean? This is the original, so you're going to be referencing this graph over and over again. So everything below x-axis gets reflected across x-axis. Done. If it's above the x-axis, nothing happens to it. Yay or nay? Yay. Go to letter B. Notice letter B has an absolute value inside of it. So I'm going to write x. All right, guys, focus, focus. F, absolute value of x, close, close. All right, negative 3, negative 2, negative 1, 0, 1, 2, 3. You guys ready? All right. F, absolute value of negative 3. What's absolute value of negative 3? Uh-oh, not everyone at the same time. 3. Absolute value of negative 3 is 3. What is f of 3? 0. Thank you. I heard someone say it. F of 3 was 0. F, absolute value of negative 2. What's absolute value of negative 2? 2. What's f of 2? 1. F, where am I getting those values from? From the original one, guys. F, absolute value of negative 1 equals f of 1. And what was f of 1? Was it 0? I can't remember. F of 1, 0. Yep. You guys were right. Say it loud and proud. 0. And then this is just 0. Absolute value of 0 is just itself. F of 0 is just, what was it? Was it negative 1? F of 0, negative 1. Negative 1. It's the internal, it's the input that's absolute value, guys, and it's whatever that is, whatever the output is the output. Absolute value of 1, it's already 1, so f of 1 is the same as when x is negative 1, so 0. F of absolute value of 2 is just 2, so f of 2 is just 1. And then f of absolute value of 3 is just 3, and f of 3 is just 0. Plot those new values. Negative 3, 0. Negative 2, 1. Negative 1, 0. 0, negative 1. 1, 0. 2, 1. And 3, 0. Yes, ma'am. Okay, what? Tell me again.
How do you end up with 0 when x is
F3. F3. I'm always referencing my original. Yeah, this is the original. This is the outputs and inputs. I'm always referencing this. See? I'm referencing this over and over again. Ask.
How did you get 0 from negative 3? Like, most of your y's are 0.
F of 3 is 0. When x is 3, the y value is 0. So f of 3 equals 0. When x is negative 3, you're over here. Negative 3 comma negative 3. So f of negative 3 equals negative 3. No? All right, guys, real quick. Maybe I assumed too much. From your Algebra 2 days, y equals f of x. Understand that this is your input, and the output of this is your y. So if you see f of x, I mean, this is the same thing, right? That's what I'm doing. So if I tell you f of negative 3 equals negative 3, that means when your x value is negative 3, your y value is negative 3. If you see f of 3 equals 0 like this, that means when your x value is 3, your y value is 0. You got to ask me these things, guys, because I'm just going to assume that we know them because we've had Algebra 1, Algebra 2, and we're in Precal. So I just assume that we have a certain understanding. And if you guys don't tell me anything, I'm just going to keep going. So you got to ask me. You got to tell me. So, and I just represented the values in two different ways. I have a table on the right, and I have it in function notation, I guess, if you want to call it that. F of x equals y. So it's the same. What's up? Ask. No, it's negative 3, negative 3. What table? Which table? The new one? For B. Okay. B. Because this time, look what my input is. My input is f of absolute value of x. So what I'm trying to do is I want to know how this graph looks. F, and then look, what's my x value? All right, guys, focus. Shh. My x value is negative 3. So when I take the absolute value of negative 3, that is 3. So then this behaves like f of 3. And then I look up what f of 3 is, and f of 3 is 0. Do you know what I mean? Okay. All right, so what happened here, guys? So what happened here is everything that was in quadrant 2 and 3 got deleted. Whatever was in quadrant 1 and 4 got reflected across the y-axis. Really, the better word is probably mirror. And that's obvious because, look, everything in quadrant 2 and 3, the x values are negative. Do you guys see that? So I'm going to put everything in quadrant 2 and 3 was deleted, comma, quadrant 1 and 2 is mirrored. I'm going to put that in quotes. Did I spell mirrored correctly? M-I-R-O-R-E-D, mirrored. I feel like it's not, but that's fine. Is mirrored across y-axis. How do we feel? Easy, right? What's up, Aguilar? Tell me. Dime. You good? Okay. Sorry, miss. Oh, you're good, miss. Sorry. There's a safe space. Ask. I know it's towards the end of the day. Sometimes I get a little sassy. But I want you to ask. So please ask. Letter C. On the axis provided, sketch the entire graph of y equals f of negative x. So check it out. Check it out, Reese Wentz. That negative in the front just means what's the word? I'm looking for another word. Positive to negative, negative to positive. Can't believe I lost that. Not reciprocal. I guess opposite is fine. Polarity. Why did it take me so long to figure that out? Change the polarity, guys. So whenever you hear someone say change the polarity, that means if it was positive, change it to negative. If it was negative, change it to positive. So I'm going to write here what that means real quick. Change polarity. Have you guys heard about the poles? It might change pole, right? North turns to south, south turns to north. So change polarity means change positive to negative, comma, negative to positive. Sorry for my bad handwriting. All right, here we go. X, f of negative x. Negative 3, negative 2, negative 1, 0, 1, 2, 3. All right, ready to read, twins? Because you guys are going to answer this question. So, negative, negative 3. Negative times the negative is a, so you're just changing the polarity. What is f of 3? Look at your original. What's f of 3? 0. That's all you're doing. See? This one turns to f of 2. What was f of 2? 1. This one turns to f of 1. What was f of 1? 0. This one's just f of 0, so the f of 0 always stays the same. What's that one? Was it negative 1? This one turns to f of negative 1. What was that? Was it negative 1? Yeah. And then this one turns to f of negative 2. And I think that was negative 2. And then this one turns to f of negative 3, which is, plot those points. Negative 3, 0, negative 3, 0, point. Negative 2, 1, negative 2, 1, point. Negative 1, 0, negative 1, 0, point. 0, negative 1, 0, negative 1, point. 1, negative 1, 1, negative 1, point. 2, negative 2, 2, negative 2, point. 3, negative 3, 3, negative 3, point. Connect them. What do you notice? Compared to the original. It just reflects, or it just flips. Yeah, you can say flips. What'd you say? Flips or rotates? Yeah, that's fine. You can say rotate on y-axis. I don't know. People might confuse rotate with rotate, circular. So maybe not rotate. Flip, reflect, reflect. Reflect everything. Across what? Across y-axis. Reflect everything across y-axis. All right. Take a guess. What do you think is going to happen to this one? It says 1/2 x. So do you guys remember your stretch compress? Oh man, you guys don't remember that? Who remembers what this 1/2 in the front does? Does it horizontal compress by a factor of half? Or does it stretch it by a factor of 2? It's one of those two. You guys don't remember? Not even a little bit? It stretches it by a factor of 2, the reciprocal of half. Negative 6, negative 4, negative 2, 0. Don't worry, you'll see y right now. 2, 4, 6. Don't worry, you will see y right now, so you will no longer be robots. Chav, how did you know those were the x coordinates? Well, I already knew that it stretches it by a factor of 2. Negative 3 times 2 is negative 6. Negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. Chav, but how did you know? Like this. Look at this, guys. These are, okay, I guess I'll tell you. It's not a secret. It's not a secret. Look at this. These are the only outputs I know. These are the only ones. F of negative 3, F of negative 2, F of negative 1, F of 0, F of 1, F of 2, F of 3. Those are it. Those are it. That's it. So look what happens if I plug in a negative 6. So I write F of 1/2 times negative 6. What's half of negative 6? And that's the only output I have. F of negative 3 is negative 3. See? So look at this. F 1/2 times negative 4. What's half of negative 4? So F of negative 2 is negative 2. I'm just taking those values from the original. F 1/2 times negative 2. What's half of negative 2? Not everyone at the same time. Positive or negative? Negative. F of negative 1, I believe, was negative 1. Half times 0 is always going to be 0. So that's still negative 1. F 1/2 times 2, that's just, what's half of 2? I don't know. Half of 2 is, oh, I said half of 2. I'll replay it. Maybe I did say that. What's half of 2? I'm recording. Half of 2 is 1. What's f of 1? Was it 0? I can't remember. Short-term memory. F of 1. F of 1 was 0. Good job. 0. F half of 2, or half of 4, sorry. What's half of 4? 2. What's f of 2? 1. And then finally, half times 6. What's half of 6? 3. And what's f of 3? 0. Plot those points. Plot those points. Sorry, guys. Sorry for that voice. Negative 6, negative 3. Negative 4, negative 2. Negative 2, negative 1. 0, negative 1. 2, 0. 4, 1. And 6, 0. What happened? What happened? Oh, what happened? It was a horizontal what? Stretch. Horizontal stretch by a factor of what? 2. Take the reciprocal of whatever the coefficient is in front of the x. So now you're no longer robots. All right, focus on these. Focus, guys. Focus, Sanchez. Now you're no longer robots, and you know why. Cool or not cool? Yes, ask. Oh, because this one has a stretch by a factor of 2, so I did 3 times 2. So 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2. You know what I mean? So just, your x values have doubled. Cool or not cool? And by the way, obviously we're just doing this like in 2 minutes. This was a whole, 1 week or 2 weeks in Algebra 2? Maybe even more. So take a guess. What do you think happens when you see this? Take a guess. It's a shift. How many times? 1 to the right or to the left? Right. To the right. And all this time you were like, I don't know why it's 1 to the right. It says minus there. Let's talk about why. Horizontal shift, comma, 1 right. Well, if I know that I'm moving 1 to the right, I'm going to start at negative 2. Negative 3 turns to negative 2, right? So negative 2, negative 1, 0, 1, 2, 3, 4. I'm going to write f of x minus 1, close. And you're going to see why it moves 1 to the right here. Check it out. Plug in a negative 2 in for x. F of negative 2 minus 1. OMG, that's f of negative 3. And f of negative 3 was negative 3. F of negative 1 minus 1, that was f of negative 2. And f of negative 2 was... Not everyone at the same time. Yeah, negative 2. F of 0 minus 1 is f of negative 1. And that was... What was f of negative 1? Was it negative 1? Yeah, I should have just made up my own problem instead of taking to this one, because I don't really like it now. I liked it when I was typing it, but now I'm like, it's not very good. F of 1 minus 1 is just f of 0. And f of 0 was negative 1. F of 2 minus 1 is f of 1. And f of 1 was it 0? Bless you. 0. F of 3 minus 1 is f of 2. And f of 2, was f of 2 1? Okay. And then finally the last one, f of 4 minus 1, that's f of 3. And f of 3 was back to 0. Plot those points. Plot those points. Okay, I'll stop, guys. Negative 2, negative 3, point. Negative 1, negative 2, point. 0, negative 1. 1, negative 1. 2, 0. 3, 1. And 4, 0. Look at this, guys. OMG. The original just moved 1 time to the right. So from now on, anytime you see f of x minus 3 or f of x minus 5, that means that you move to the right 3 times or 5 times. I know this is not the most exciting. You guys are like, I already knew this. So maybe, How do we feel? Do we feel okay? Don't yawn. Okay, don't worry. Now things are going to get exciting now. Okay. Here we go. Now things are going to get exciting because now we're finally working back to sinusoids. All right. Here we go. We're going to go slow. You guys ready? Okay. So hype up yourself. Hype yourself up. Okay. Okay, I'll stop. All right. The figure below shows a quarter cycle of a sinusoid in degrees. And I put the awkward emoji because for some reason you guys just perform better in degrees. It says write a particular equation for the wave. All right, this is a quarter of a cycle. So that means that I'm either going from a point of inflection to a low point to a point of inflection, or a point of inflection to a high point, or a high point to a point of inflection. Does that make sense to you guys? So that means this 3 has to be a low point. I can see the curvature there is changing. And that 8 has to be a midline. So from there, I can see that the amplitude is 5. What is 8 plus 5? What is it? 13. Put 13 up there. Do that. Do that first. I marked my low. I marked my high. The amplitude is 5. I'm going to say over here on the side, amplitude equals 5. Of what? Y equals A. The only thing we know right now is cosine. So B, X minus C, close, plus D. And don't worry, we're going to give you guys a chance. You don't have to write that down. You can just listen for now. I'm going to upload this video to the web, so you're good. Or to YouTube. All right. The period. Well, let's find out what the period is. This quarter cycle from 17 to 24, the difference is 7 degrees. So I can already tell that my period is going to be 28. But don't worry. I want to graph this. So I'm going to go another 7 degrees to the left. So I'm going to say this is like 10 degrees right here. And you go from a point of inflection. At 10 degrees, you should be at a max. So at 10, put a point at 13. And then I'm going to go another 7 degrees to the left. So I'm going to say 3 is like right here. And I'm going to be at a point of inflection. So put a point at 3, 8. All right. From the 24, I'm going to go another 7 to the right. So another boom. So I'm going to put right here. I'm going to say that's 31 degrees. So put a point at 31, comma 8. And then I'm going to go another 7 degrees. So that's going to be 38. At 38 degrees, put a point at 38, comma 13. Wherever you have maximums, put an upside down bowl, aim it towards the points of inflection. Wherever you have minimums, aim it towards your points of inflections. Let me see how I look. And look, it looks like that. Yay. Are we okay so far? Okay. Nothing crazy. All right, here we go. My equation. Y equals A cosine, open parenthesis, B, open, X minus C, close, close, plus D. Your calculators might already have these answers because we did them earlier. Focus, Sanchez, focus. All right, what is my amplitude? What's the amplitude, guys? 5. So Y equals 5. Cosine, open parenthesis. The B value. The B value is, so I'm going to go to the side. The B value is either 360 divided by period or 2 pi divided by period. Which one am I going to use? 360. So I'm going to go 360. I'm going to divide it by 28. Does everyone know how I got the 28? I either did peak to peak, 38 minus 10, or you can do 7 times 4, whichever one you think is easier. Take your calculator, go 360 divided by 28. You're going to get a decimal. It's going to go forever. As soon as you see that decimal go forever, turn it into a fraction. Math, fraction, enter. 90 over 7. So there's my B. 90 over 7. So 90 over 7, open parenthesis, X minus, what's the first peak you see left to right? 10. Put a 10, put a degree symbol because it's a degree. Close it twice. What's my midline? Plus 8. Okay. Yes, miss. Oh, I thought.
Real quickly explain why you got 28.
Yes. I did peak to peak, or you could also do 7 degrees times 4. You see that 38 degrees? That's a peak. You see that 10 degrees? That's a peak. So 38 minus 10 is 28. So my period is 28 degrees. You could also do, remember this was a quarter, so you could also do 7 degrees times 4, which will give you the 28 degrees as well. Okay. Check it out. I believe I already have it here because, yeah, they're all here. So try not to look at Y2 just yet because you're gonna get confused. So don't look at all these values. If your calculator has those answers, leave them alone. I'm gonna leave them there because it's so much faster to just reference them. There it is. Y1, 5 cosine 90 over 7, X minus 10 plus 8. And my window, here's my window. If you want to change your window to look like that. X min negative 1, X max 40. You know what? I don't want to cheat you of an education. I'm going to reset everything because I want to do everything from scratch. I want to do the same thing that I did with first period with you guys. All right, so give me the equation again. So what was my equation? 5 cosine, and then 90 over 7, right? Alpha y equals, enter, 90 over 7. And then move to the right, open another parenthesis, x minus 10, close, close, plus 8. Now I'm going to click on window. Under window, so here's what I want. I want to go a little bit to the left of 3, so I'm going to go to 0. So 0. X max, I want to go a little bit to the right of 38, so I'm going to go to 40 or 41. And then X scale, doesn't matter on that one. I'm going to go by 5s. Y min, let's see. The lowest I go is 3, so I'm going to go a little below that, so I'm going to say 0. And then Y max, I want to go a little higher than 13, so I'm going to say 16. And then Y scale, let's go by 5. That one doesn't matter. Push graph. Oh, do you see my mistake? Yeah, good thing I did it again. I have it on radian foam. Is this a radian or is this a degree? Yeah, there is a degree. So go to mode and where are you? Degree. Okay, now I'll do it correctly. And there it is. Are we okay so far? Now I am going to put the 8 in y6. So I'm going to scroll all, or y7, 8. I want to see that midline. Okay, there it is. Yay or nay? No, don't worry. It's about to get exciting. I wish I had a button to push fire all over the place. All right, here we go. Yeah, you know what? I'm going to get a fog machine. I can do that. And I'm just put... Does anyone have asthma? Oh, okay. No, never mind. Fog machine has to... We're going to have to wait. Yeah. All right, here we go. No, the fog machine won't set off the sensor because it's fog. It's water mist. I don't see how I would set it off if it's just vapor, water vapors. Yeah. Okay. Anyways, or maybe it's set off. Okay. It doesn't matter. All right. Sorry, guys. Sorry. Let's focus. Go to the next page. All right. Here we go, guys. This is the same graph. I did all this by design. Let me know. I accept criticism. I did this on purpose for a reason. The equation we came up with in class, y equals 5 cosine, open parenthesis, 90 over 7, open parenthesis, x minus 10 degrees, close, close, plus 8. Sorry if I sounded like a drill sergeant. That's the equation we came up with, right? It's the same graph, guys, as previous. My high is 13, my low is 3, my midline's 8, and those are the same values I got earlier. Are we okay so far? So look what it says for letter A. They want me to write a cosine with a phase displacement other than 10 degrees. So they want me to rewrite this, but with a different C value. Well, where else do I have a peak? At what? I heard you say it. At 38. So let's write the same thing, but with a 38. 5 cosine. It's the same wave, so keep the B. X minus 38 degrees, close, close, plus 8. And then to check to see if this is true, I'm going to type it into y2 and see if I get the same thing. So on y2, I'm going to put 5 cosine alpha y equals, enter, 90 over 7. 90 over 7. Open parenthesis, x minus 38, close, close, and then plus 8. And then I'll push enter for graph. And look at that. It's the same graph. Yay or nay? Okay. Are we okay so far? Okay. Here we go. Let's continue. Cool or not cool? Look at this. This is the first time we have sine. Chav, I don't know how to do it with sine because I've never graphed sine. Okay, we're going to go slow. I need everyone's A game because we've never graphed sine before. Do a side note over here on the corner. Y equals sine x looks like this. And y equals cosine x looks like this. It's still a wave, but okay. Here's what I want you to notice, and don't freak out. The sine x, when the x value is 0, has a point of inflection going right through the origin. Does that make sense? So I want you to observe that the point of inflection is when the graph of f of x or sine x is when the wave is increasing. Do we notice that? You can either say I need a point of inflection when the graph is increasing, or you can say I need a point of inflection from going from concave up to concave down. Child, what are you talking about? Okay. On this graph here, can you tell me where I have a point of inflection where this graph is increasing? Where and where? This graph in green. Where do I have a point of inflection where f of x is increasing? At 3, and I have another one at 31. So if you're going to use sine x, you're not going to use 17, because that is a point of inflection, but you're not increasing. And you're not going to use the one way over here. You have to either use 3 or 31 degrees. Does that make sense to you guys? So here we go. Everything else is the same. It's the same wave, so it has the same period, same amplitude, same midline. The only thing that changes is your C. For your C, you got to use the point of inflection where the graph is increasing. Cool? y equals 5. Put sine, instead of cosine, put sine. And if we're using sine, we have to use a point of inflection where the graph is increasing. 90 over 7, open parenthesis, point of inflection concave up to concave down, or x minus, let's see, x minus 3, point of inflection increasing. Put a degree symbol, plus 8. And there it is. That's my graph. Cool or not cool? All right, let's check to see that it's correct. So here's my calculator. I'll go to y equals again. And this time I'm going to type the sine. 5 sine. And I'm going to do again alpha y equals, enter, 90 over 7. 90 over 7, open parenthesis, x minus, was it 3? Close, plus 8. It was 3, guys, or no? Okay, so this one should be black. So let's see, graph. And look at that. It's the same graph. Cool or not cool? Do we understand it? I know, guys, I know having math last period is hard. Okay, this is a new concept, so everyone put your pencils down. I just need you guys to take this in. All right, ready? Do you guys know this says cosine with a negative vertical dilation? So this is what it means. A negative vertical dilation means I'm going to put a negative in front of my amplitude or in front of the cosine. So tell me from your algebra 2 days, and it's okay if you don't know, what happens when I put a negative in front of f of x? Okay, reflected across what? The x-axis. So everyone put your pencil down because I need you guys to really take this in. All right, so if I put a negative, do you agree? If I put a negative in front of this curve right here, that all that would do, and I guess I got to change it to burnt orange because I don't want you guys to confuse the colors. If I put a negative in front of that all that would do is just whatever the maximum turns into a minimum and whatever the minimum turns into a maximum. Do you guys agree with that statement? Because you just told me it gets reflected across the x-axis, but then my shift, my midline's 8, so it gets moved up 8. Does that make sense? Okay, so if I told you I want this burnt orange curve, just listen, don't write anything down. If I told you that I want that burnt orange curve, it has the same amplitude, it has the same period, everything is the same, except now that my lows are highs and my highs are lows. So if I told you I want the equation of that burnt line, you would say, oh, I know that one. Y equals 5, cosine, open parenthesis, 90 over 7, x minus, where do I have a peak? At 24? 24 degrees, close, plus 8. Don't write this down, just listen. Do you agree that that is the equation of that burnt orange line? Okay, but do I want the burnt orange line? No, I want the green line again, but with a negative in the front. Does that make sense? Well, if I take this burnt orange line and I put a negative in the front, that burnt orange line will turn into the green line. Do you guys see that? So if I take this one right here, the burnt orange, and I put a negative in front, that high will turn to a low, that low will turn to a high. Yay or nay? That is my expression, guys. That is. Math Life, hashtag. Bam, push a button for flames and everything. Okay, so now you can write. So here it is, guys. This is my expression. Here's my expression. Negative 5 cosine 90 over 7 parenthesis x minus 24. Was it 24? Yeah. 24 degrees, close, plus 8. Does that make sense to you guys? Yes, good. Good. You want to drink some water, man? Go for it. Bam. Jump around. Okay. We should make a concert here, guys. Should we put music? I got some music right now. Let's see if it connects. All right. I don't think it's going to connect, but if it does. Hey, where'd my speaker go? Did they take it? I think my seniors took it. I don't see my speaker. Did Alvarez take my speaker? Is there a speaker in that table somewhere? Dang, Alvarez and Estrada took my speaker. They were using it earlier. That's fine. All right, here we go. The sine value. It's the same thing, guys. The burnt orange line. Give me a point of inflection on the way up for the burnt orange line. 17. So that's what we're going to use. Put a negative in the front. Y equals negative 5 sine, open parenthesis, 90 over 7, parenthesis, x minus 17 degrees, close, plus 8. Chavez, what are you doing? It says here that they want a negative in front. both of these better give me the same curve. If not, I'm fake. And I'm not fake, guys. So here we go. If I go to y equals and I go to y4, I'm going to put a negative. Negative 5 cosine alpha y equals, well, enter, I guess enter for number 1. 90 over 7. 90 over 7. And I already forgot my, dang it. I already forgot my, what was my shift? X minus what? 17 for the cosine? 24? Which one is it? 24? 24 for the cosine, and close, plus 8. All right, here we go. For the sine, negative 5 sine 90 over 7. I'm just going to put 90 slash 7. It's the same. 90 over 7, open parenthesis, x minus, this one was what? This one's 17. Close, plus 8. Okay, here we go. If I push enter, I better see the green right over my curve, and then I better see the, did I say green? Pink right over my curve, and then the green right over my curve. Graph. Look at that. There's pink, and there's the green. They're all the same graph, all of them. If I go to my table, look at my table here. They're all the same graphs, over and over. All of them have the same values all the time. Yay or nay? Yeah, see guys, it's all simple. It all makes sense. We're not robots.